Hi guys, welcome to this lesson. In our previous lesson, we talked about natural numbers. In this lesson, I'm going to take you through whole numbers, and in the subsequent lesson, we talk about all the subcategories of numbers in the real number system. So, what are whole numbers? Whole numbers evolved with the right idea that came in humanity's mind that how was zero invented? Why zero, right? So you realize that natural numbers gave birth to whole numbers, and whole numbers is a set of numbers with a minimum number to be equal to zero. So the difference between whole numbers and natural numbers is simply the invention of what's zero. So initially, counting numbers remained the popular numbers over the years, and later zero was invented, and that sounds very ridiculous. Why zero? Humans realize that there are sometimes situations where you don't have anything, your account is empty, there is nothing. So how do you then describe that numerically? So that brought about the idea of zero. So if I have zero added to 1, added to 3, added to 4 in that order, I'm going to get a set of numbers which we are going to call whole numbers, generally represented as capital W, but with all the legs doubled, right? With all the bends legs doubled. Okay, so you see that as a symbol of whole numbers. So minimum number of natural number whole numbers is zero, and the only difference is that I'm adding zero to natural numbers to give me whole numbers. Most of the properties remain the same except the few things which the zero will make a difference. So whole numbers simply follows the additive identity. Okay, additive identity. So the additive identity of zero, one powerful property is that when I add any number to zero, I still get that same number. So that is equal to zero, which is only a property of whole numbers here, not in natural numbers. Okay. Then also whole numbers are closed under multiplication, because when I perform any multiplication of any two numbers here, I'm going to get the resulting number to be a whole number. Okay. When I perform addition, so addition is also said to be closed, I'm going to get another whole number, right? But when it comes to subtraction, in subtraction, I may or may not get. Because of that, we say subtraction is not closed under whole numbers, as well as division in this sense, which is also not closed under whole numbers. Whole numbers are said to be well ordered. Well ordered. Well ordered. So when I say whole numbers are well ordered, it means that if I have A which is less than B, less than C, or less than D, I'm creating an ordering here. So in reality, the set of whole numbers, which is 0, 1, 2, 3, they are ordered by what? Less than or equal to. So I have 0 less than or equal to 1, equal to 2, less than or equal to 2, less than or equal to 3, in that manner. So that is how they grow. So here, if the rule says that A is less than B, that is the order for whole numbers, or A is less than or equal to B, then we can say that A plus C should also be less than B plus C. Yeah. So this means that our system is very well ordered. What it's saying is that if I have two numbers which exhibit the relationship that the first number is less than the second number, then if I add a common number to it, that system should still be stable, because I have not changed it, but what I did is I added the same quantity to the left, the same quantity to the right. So generally, you say that natural numbers are a subset of whole numbers, and it grows that on. So see you in the next video as we talk about integers. See you then.